Okie dokie. Okie dokie. Thank you.
It wasn't me.
Okay. Thank you so much for reminding me. So we went over today that our math target is very similar to last week, except we're not doing addition and subtraction. This time we're doing multiplication and division, and hopefully I can do it this time without making mistakes, right? So we talked last time about the situation equation,
Miss Norman.
and the solution. Wow. Carson is on it today.
More with a little
The solution equation. Right? Okay. Hopefully you can see that all right. You want to tell us about these, Carson?
upside down V.
The upside down V.
Yeah, it's like a little mountain, then you have a total here, and then you have your two numbers.
Oh, that's true. That's true. Now, cool, friends, I've got some people who are not quite with us. So I'm going to wait till everybody's focused and quiet. Hey, Connor, put that away for now because I need you with us for math. Guys, put that stuff away. I need you with us for math. Okay, no notes, no pictures.
I know who my
Yes, Brinley?
favorite students are.
Please. All right, Brinley's going to talk to us about situation equation and solution equation.
Situation equation is
It's not hard.
like 526 plus blank equals that answer.
Right, I'm going to put her example up here, right? So she said 526 plus, let's give it a variable, right? We'll say plus n equals 527. We could figure out n pretty fast, right? Whoa, it's still Brinley's turn. Shh.
And the
Why
solution
did you say
equation
something?
is like
I mean, all of it.
to solve it. Like actually.
Right. So the situation equation is what we are taking right from the word problem. Riley.
Yeah, how you doing?
Shh, Italian. Shh. The situation equation is what we're taking right from the story problem.
That's a hard question.
But the solution equation is the actual equation that we use to figure out what our variable is, right? In this case, we would have to do 527 minus 526 gives us 1, and then we know that our variable is 1.
So hard.
So for each word problem, we are actually looking for two equations. Two equations. Our situation equation, the one that we get right from the story problem, and then the solution equation, the actual equation that we use to solve. So, let's see here. Ooh. Yes, Rex.
So, is it addition and subtraction algebra the same thing as multiplication and division? Because for addition, you do subtraction, and when it's subtraction, you do addition, and then when it's multiplication, you do division, and when it's division, you do multiplication.
Let's double check today and find out. But yeah, usually we would do the opposite to figure it out, right? So yeah, let's double check today. And I'm going to go back to what Carson said earlier. He was talking about our break apart model, right? Where we have the hole at the top, we have a part, and we have to figure out the other part, right? Well, today we're not going to actually use the break apart model. We are going to be using an area model because we are, I'm going to leave that. Because we're doing multiplication and division, and we already know how to find the area of something. We already know that it's length times width equals the area, right? So this makes it really easy. It's going to be this times this that gives us the area. So let's think about this for just a moment. You don't even need your whiteboard yet. I just want you to think and then help me to fill in our area model here with the right numbers, okay? You ready? In a school gymnasium, 375 students have gathered for an assembly. The students are seated in 15 equal rows. How many students are seated in each row? Let's fill in our chart here. fill in our chart? I've heard from Brinley and Braxton, and I'm so glad you guys know it. I need to hear from someone. I've heard from Carson, too. Who else can help me?
What was the question?
One more time. In a school gym, 375 students have gathered for an assembly. The students are seated in 15 equal rows. How many students are in each row?
Wait just a minute.
Where am I going to fill in some numbers on my chart? Even though it's not asking for area, I know it's not asking for area. We're still going to be showing it and demonstrating it on an area model just because it's a model that we understand and we can use. Andrew?
So you take the whole number of students and then you divide it by the number of rows they can sit in?
Okay, so I'm going to take the whole number, so that's going to go inside, okay? Then what would I fill in on my blanks here?
We divide 375 by 15.
And then this is our variable, right? I'll put S for students because we want to know how many students are in each row.
D for dinosaur.
Okay? All right, does that make sense? Okay, so our situation equation is going to be 15 times S equals 375, right? Length times width equals area. Even though we're not talking about area, this is just a good visual for us. It's a good model because it shows something times something equals something. What is our solution equation? Raise your hand and let me know what our solution equation would be. Riley? Thank you for raising your hand.
Sorry, 15 divided by 375.
Oh, you're so close.
375 divided by 15.
Yes.
I dropped my pencil.
Perfect. Our solution equation is 375 divided by 15 gives us S, right? Oh, so
S.
Braxton, it is the opposite on this one, right?
Is
Yeah, for sure. If I want to know what this one is, I've got to actually do the opposite of what my sign is. I have to divide. Landon.
It's a turtle.
What is it? 25? 15 times 25 is 307. That sounds right. So 25 students. Or we could even say, since we're doing algebra, right? Boom. Thank you, Kaden. S equals 25. Great job. Oh, see, you guys are going to be just fine with this. I love it. You ready for another one? You are big brains. Get out your whiteboards.
That was great.
What's that? I might do it again later.
I found my
Okay, fine. We'll do a row race.
Raise your hand.
Oh, maybe I can't.
No, it's for a kid.
Miss Norman, roll five.
3.
What?
Miss Norman,
1, 2.
Oh.
Okay. You ready?
Hey,
You have your
Miss
markers
Norman.
ready. Yes, sir.
Not the same substitute as last time.
She was a big Karen.
She was looking at me.
Well, she did say that you guys were amazing, so.
She was Chunky Karen.
Who?
Or substitute.
That's right. We didn't. There was that Friday after, and we didn't meet together, and so we didn't get to talk about
She was
stuff.
staring at me every single second. I'm just looking at her like, why are you looking
I
at me?
wrote that in my plans. I'm like, watch Maddox.
Miss Norman. Miss Norman. I was over there doing the freaking Harriet Tubman thing, and she's yelling at me for listening to music.
But did I tell you you could listen to music?
I wasn't listening to music. It was the Harriet Tubman thing.
Oh, okay.
And be the
I'm sorry about that.
And then she's
Well,
yelling at me. She's like,
my
we're
report from
listening
her was that you guys did so great. So I'm sorry if she wasn't
then
super
we're-
amazing. But
Did we get signatures?
yes, let's talk about it in a minute because I really want to finish. We're recording our math
Hey,
lesson right
hi.
now. And so let's keep going with our math
Hi,
lesson.
hi.
Shh, thank you. We'll keep going and talk about the sub a little bit later when we have a little more time, okay?
If you do ever get a sub again, please give Miss Jensen. She's really nice.
Yeah.
She's great.
Yeah.
Oh, I'm going to let her know that you guys think that. Thank you. I'll try. Okay, let's move on. You guys ready? Get your markers ready.
Oh yeah, you weren't here. You were at.
Now this one is an area 1, so totally fits. Here's what I'd like you to do first.
Oh, we're Colonel.
We're going to fill in our model. So everybody make your rectangle right now.
Box.
It could be a square or a rectangle. Either way will work. Okay.
Box.
Okay, listen carefully.
Have
And I would like you to label this with the appropriate numbers. Here we go. And then after that, we'll move on to the situation equation and the solution equation. A floor shaped like a rectangle. Oh, it has to be a rectangle. Haha. A floor shaped like a rectangle has a width of 9.5 feet. So 9 5/10 feet.
I really don't like this.
And an area of 114 square feet. What is the length of the floor? I'm going to read it one more time. You ready? A floor shaped like a rectangle has a width of 9.5 feet and an area of 114 square feet. What is the length? So first, label your model. Show me what you got. I'll write the numbers up here if by chance you've forgotten. We've got 9.5 is the width. The area is 114. Thank you, Carson. All you have to do is label your model. Perfect.
I got
Thank
the
you.
best label.
Good.
I got the best label.
There we go. There we go. Ooh, switch those around. Chloe, switch those around. Thank you, Connor. There you go, Dylan. Thank you. Ooh, perfect, Maddox.
Hold on, I'm almost done.
Yes, and then that side, let's erase that A because the area is going to be on the inside, not on the outside, but all your numbers are right.
Norman, I got the best.
Thank
number
you,
letter.
Braxton. Good job, Brooke.
I got the best letter.
D?
Dinosaur.
Yes. Label, give me a label like this. Thank you, Saraya. Good job, Jackson.
Wait, do we need to solve it?
Now, hang on.
There we go.
Erase your boards. Good job, Italia. You got it. Erase your boards. Erase, erase, erase. Please tell me what our situation equation looks like. The situation equation. In fact, if you have to think about it, let's remember that length times width equals area. That will help you with our situation equation. Ooh, good. Give me a variable. Let me read it one more time. A floor shaped like a rectangle has a width of 9.5 feet and an area of 114 square feet. What's the length of the floor? Yes. But give me the situation equation. The situation. Yes, and what's going to be in your blank? Which one don't we have? We've got width, we've got area. No, look right here.
Dinosaur.
We need the L for length. It's an L. Oh
Maddox.
boy.
Maddox.
Oh boy.
Is Maddox my dog now?
There.
Switch your sign because we're not dividing yet, right? We're just multiplying in the situation equation. Almost. That's right. That's correct. Good job, Lucas. Okay. Yes. Good, Brooke. Yes. There we go.
I
You're
did it.
close. So our situation equation is exactly what we're taking from the problem.
9.5
We are
times
saying-
dinosaur equals
Oh,
114.
Mrs. Norman's turn. We're saying that 9.5 times
Dinosaur.
the length will equal 114 square feet.
So we
Okay.
just don't have width?
That's our solution, or situation equation.
I did it.
Now, put on your board what the solution equation will be. What's the equation that we're going to use to actually solve for L?
That's a tag.
There it is. Yes, there we go. It's an L. It's an L. It's a lowercase L. Good. Once you've shown me, very nice. Thank you. Once you've shown me, yeah, solve. Let's see what you get. Do you have it, Lizzie? Okay, 1 sec. Good job, Brooke. Good, Eva, thank you. Okay.
I got the superior answer, Landon.
112. We know that 9. Maybe I should make this look more like an L so it doesn't look like a 1. 9.5 times L.
No, it's 5
How am I going to figure out how it's
What do you want? Oh, that hurt a lot.
Oh, Riley, you don't need any sound effects. Lucas, you were super close.
114 divided by 9.5. Did you do 9.5 divided by 114 really what? Did math.
Okay, so for our solution equation, eyes are right up here in the front. Voices are up. Our solution equation should look like 114 divided by 9.5 equals the length. Now, you guys might have set that up a little bit differently, but I think we're both saying the same thing. So here's our solution equation, and when we actually do it, then we have to write it like this. 114 divided by 9.5. Right? And if you did it right, is we would scooch over our decimal, scooch over our decimal, and you got 12. Right? Yeah.
Yes, ma'am.
There we go. Okay. Let's try it one more time. We just did it without a decimal. We did it with a decimal. Now we're going to try with fractions. Fractions. Get your markers ready. Listen to the problem.
Turtle.
Friend, control yourself.
I can't.
You can do it. I'm going to wait till it's silent so everybody can hear. A pastry chef divided a ½ block of cream cheese into 4 identical pieces. What was the weight of each piece? So, the pastry chef divided a total of a ½ pound of cream cheese into 4 pieces. Now, what I would like you to do, I'm not even going to do the model. Well, I'll make the model for you.
I already know the answer.
Good Lord.
Take a
It's
look.
not
No, not quite yet. I actually want to pause and talk about this one a little bit because a lot of us might get confused on this and say, well, 4 should go inside the box and ½ should go on the outside, right?
Maybe.
Well, let's think about this for a moment.
Bad.
Sometimes, hey
Box
Connor,
is
head back to
superior.
your seat, please. I need everyone listening because this would be a very common mistake. In fact, I should have let you make this mistake.
Box is superior.
Normally, we take the biggest number and we divide that by a smaller number. But if you listen to the problem again, it says that a pastry chef divided a ½ pound of block of cream cheese into 4 identical pieces. So I'm starting with a ½ pound of cream cheese, and then I'm dividing it. Even though the half is a smaller number, it still goes into the middle of my box to divide. It is still what I'm dividing, even though it's a smaller number. So I am actually saying 1/2 divided by 4, right?
Yeah.
Does that make sense to you?
Yeah.
Yeah.
We do not always divide the bigger number. Sometimes we divide the smaller number into parts. It's just like if I say, well, I have a half a bag of chips left in my pantry, and my friends come over, my 3 friends come over, so there's 4 of us total, and we divide that half a bag of chips between us and eat the rest of it. How much of that bag of chips do we get to eat?
Like
No, you'd each get some. You just wouldn't get, it wouldn't be 4 divided by a half. It's a half divided by 4. Okay.
Miss Norman,
Yes, sir?
1/2 is always going to have to be by 0.5, right?
Yes, but I still want you to keep it a fraction this time.
You said yes, sir.
Because we are reviewing and going back to working with
Hey,
fractions.
Miss Norman, couldn't it be 1/8 because 1/8 plus 1/8 plus 1/8 plus 1/8 equals half?
Yes.
Yeah.
Yeah, absolutely.
Mentality math.
Okay.
Fox
So-
is superior.
Oh, Carson. Oh, you know what they're going to say? Why haven't you put in your lunch choice today? We tell them I'll put it in right now.
Look on the wall in the black
Actually, Carson,
What?
who's on my lunch choice? You just
I
gave
said
that to
it
them
is, I
over the
was
phone.
already
Go ahead and answer.
Already empty.
Hello.
Welcome to Chile.
Hi, welcome to Chile.
Why did you say welcome? You said it's whenever somebody walks into the class.
Thank you. That way I don't have to stop our recording. So
Nunca me acuerdo.
Carson, you should be
Okay.
No, Carson.
Okie dokie. I am so sorry for that interruption. That's my fault. Shh, listen up. Connor. Okay, so based on this model, and let me read the problem one more time. I want you to give me the situation equation. The situation equation.
Lennon is
A pastry chef divided a half-pound block of cream cheese into 4 identical pieces. What was the weight of each piece? Good, Brinley.
I'm so smart.
Give me your situation equation.
Situation equation done.
Not quite. Not quite. You shouldn't have an answer yet. All you should have is an equation with a variable. You should have an equation with a variable.
I have an answer.
So right now, Kaden, that's great. You've got the solution equation. And Brooke, you're super close, but remember the half is our total. So switch the 4 and the half in your equation. Switch those places. Not quite, because you're giving me the solution equation. Give me the situation equation. All right, let me help you out a little bit. What we're saying is 4 pieces
Ace turtle.
times whatever weight it is, it doesn't matter the variable, right, is going to give me a half of a pound of cream cheese.
It can be.
Good job, Alexa. So,
It can be 4
oh,
16.
I need everybody's eyes right here. Put your lid on your marker for a moment.
I think.
Lids are on your marker. Eyes are right here. Thank you. So this is our situation equation. 4 pieces times whatever they weigh is going to give me a half a pound block of cream cheese. Now, hold on. I don't need an answer quite yet. Now I want you to give me the solution equation. What's the actual equation I'm going to use to solve for a W? There you go. Brinley's got it.
This Norman.
You were super close. Yes, so now you've got your situation equation. Let's do it. Switch that half and that 4, Brooke. Switch that half and that 4 in your equation. Everything else is right. I'm not starting with 4. I'm starting with a half. I'm starting with a half. There you go, Dylan. Yeah, you got it, Andrew.
Wait, can I get the right answer?
There you go, Connor.
Miss Norman.
Oh, switch those in your equation, Alexa. You're close. Put the half first. Because half is my total number or amount of cream cheese, a half a pound. I'm starting with a half a pound, and then I'm going to divide that half a pound into 4 pieces. I'm saying 1/2 goes first. 1/2 divided by what? There, Soraya. You got it. There you go,
For
Kaden.
4 years.
Aha. Close, but wait, hold on. Let me see. Nope, start with a half on your first equation. You have to start with half. Half's the total. Switch the half and the 4 in your equation, Alexa. We're starting with a half. Okay, there we go. A half divided by 4 will give me the weight of each. This is the equation that I'm looking for.
Oh, well.
A half divided by 4.
Miss Norman.
Oh, yeah. Hang on just 1 sec. Hang on 1 sec. A lot of you have been showing me the answer, and I'm so glad that you remember. Riley, shh.
But you didn't.
You'll be fine.
No, I'm not. I will not.
But I want to review a tiny bit with you on how we find this. Please quit tapping your board. You are right next to the computer where you're recording, and that will be very distracting. So if I do a half divided by 4, remember we're working with fractions, so 4 wholes looks like 4/1. We got to remember our rules about dividing fractions.
You don't work with improper fraction.
Keep the first change. Keep change flip. Keep the first fraction, right? We're keeping it. I'm going to change the sign. And then I'm going to flip the second fraction. What should the second fraction look like, Brinley? 1/4. Then we multiply straight across, right?
So 1/8, but if you minus
1 times 1 is 1. 2 times 4 is 8. There we go. So now we know that W equals 1/8.
Or it could be 1/4 if you.
And if I fill in my model, I know that 4 times 1/8 equals a half. But I also know that 1/2 divided by an 8 will give me 4 pieces. Or 1/2 divided by 4 pieces will give me 1/8. Either way. Yes, Andrew.
So this problem, 1/2 also equals 0.5, right?
Uh-huh.
So, but if you did 4 divided by 0.5, you want to get 1/8. You would get 0.1.
10?
Yes.
Let's try that.
Do 0.5 divided by 4.
Divided by 4 wholes. Okay, so I'm going to put my 0 point right here. And I know that 4 will go into 5 one time, which is 4. 5 minus 4 is 1. I've got 1 left. I'm going to add a 0. I'm going to bring it down. And I'm going to put it right here. 4 goes into 10 2 times. 4 times 2 is 8. Bring down 10 minus 8 is 2. I can bring down another 0. And I've got 4 goes into 25 times. So really it would come out to 125 thousandths, which is the same as 1/8.
How?
Let's do it. 1 divided by 8, right? Because that is the same right here, 1 divided by 8. Fractions are division. So I'm going to put my decimal right there, and we'll do it like this. 8 goes into 10 one time. 1 times 8 is 8. 10 minus 8 is 2. I'm going to put another 0, bring it down. 8 goes into 20 2 times. 8 times 2 is 16. Oh, I'm going to run out of room.
Okay.
20 minus 16 is 4. Bring down my other 0. And 8 goes into 45 times. No, I didn't outsmart him. I just have a little bit more experience. But, hey, it just shows that fractions
Andrew's brain just
really
exploded.
are division. They really are division, and fractions and decimals are just like brother and sister. They are like,
I don't have a
I would,
sister.
well, maybe like brother and brother. They're very, very similar.
I have a brother.
Fractions and decimals are like twins. Yeah, they're super similar. Okay, yes. Lucas and Braxton, take those down. Carson, can you do what? Yes, they're in the box in that top drawer. Saray, yes. Hey, what? Which one?
His name is Theo, and
What team is he on?
we used to play for BYU in college, and I don't know what team he is.
Wait, say his name one more time.
Theo, and I don't want to say his last name because everybody's gonna come for me.
No, I don't. Just say it. Maybe it'll
Theo
jump.
and Talkie.
Yes, I do know Taki Taki. BYU football. That's my thing. That's my thing. Yeah. So yay!
I don't want to hear it.
That's so cool, Sabrina. You guys, we are going to finish math during math interventions today because we're not rotating. So we're gonna finish and we'll practice some more. But that's all we're doing for right now.
She's answered the
Thank you, Mrs. Savage.
Are we gonna play this?
We can maybe do that right now.